All right, hey guys, today we're doing section 1.3 trig functions. So if you remember anything from geometry class involving trigonometry, it probably had something to do with SOHCAHTOA. And while SOHCAHTOA is not incorrect or false in any way, it is actually perfectly true and accurate. It's just a little acronym to help you remember opposite, adjacent, hypotenuse, all of that stuff. Actually, when we get to trig class, we're going to be a little bit more formal, and we're going to say, screw the acronym. Here's actually what we're talking about for sine, y over r. So remember how sine, if you remember anything about SOHCAHTOA, it was defined as the opposite leg over the hypotenuse. That's what the S, the O, and the H stand for. And so now what we're going to do is, instead of using O and H, we're going to use y and r. Similarly, instead of adjacent and hypotenuse for cosine, we're going to use x and r. Tangent is y over x. And then what's weird about this is there's actually 3 more trig functions, and this one is cosecant, this one is secant, and this one is cotangent. So kind of some new words here, but what you'll notice here is that sine and cosecant are defined as reciprocals. It's just the fraction flipped upside down. So what you need to focus on right now is which ones go together. Cosine and secant go together. It's just the reciprocal of the fraction. Tangent and cotangent go together. It's just reciprocals of the fraction. If I could explain a little bit about why we are not doing O divided by H, we're doing Y divided by R. What we have here is, you can see we've kind of gotten into this thing called the unit circle. And so if I wanted to do my angle here for theta, and I have this, what the words up here are in the definition that I skipped over up here. Math definitions are a little bit crazy looking sometimes, but if I could kind of explain what those words mean a little bit. If we were to make a triangle out of this angle, which is in standard position meaning the initial side is on the positive x-axis and the terminal side is there, which I have in blue, and here's my x, y value that I have. We don't know what it is, what the numbers are, but they could be anything. X and y are both positive in this case because we're in quadrant 1. But what if I were to make a triangle out of this? And what if I wanted to say, like, what's the sine of theta? Let's go back to, okay, sine is opposite over hypotenuse. This is what you learned in geometry class. Well, this is my opposite side, and isn't it just the y value? However high I went in order to draw that ray. And isn't this just the x? That's my adjacent side, so for sine I'm not using that. And we have this thing here that's r. R actually stands for the radius, which is weird because we are doing unit circle after all. So r is the radius, and no matter where I draw the radius, it's always going to be r, and I'm still going to have an x and a y value whenever I make my triangle. So, sine being opposite over hypotenuse, well, the opposite of this angle here is the y value, and the hypotenuse is always the r because it's always the radius of the circle. So that, my friends, is where the y over the r comes from. Okay, same thing for cosine. Cosine's adjacent over hypotenuse, but the adjacent side here is x, and the hypotenuse is r. R stands for radius. So there's a brief introduction. We'll talk more about this in class, but that is why these x's and y's are what they are. You can think about it in terms of SOHCAHTOA until you get this stuff memorized, but we are probably not going to be using SOHCAHTOA very often going forward. I want to dive into these example problems here because it goes along with this definition, and I'm going to be referring back up to this chart here. So just, that's what I'm going to be using for sine, cosine, tangent, etc. So keep that in mind. You'll probably want to have that memorized sooner rather than later. But this very first problem, the terminal side of an angle in standard position passes through the point 8, 15. So really similar to this picture up here, I'm going to draw something that looks like that, except now I know what my x and my y are. It's 8, 15. So what I'm going to do is draw that real quick. It's in the first quadrant, so I'm not going to draw the entire coordinate plane. I'm just going to draw the first quadrant. And I'm going to draw a triangle. Always drop your side down to the x-axis, meaning we never go this way towards the y-axis. Okay, it's always dropped down to the x. And if this point is 8, 15, then doesn't that mean I went right 8 and up 15? So I now know 2 out of the 3 sides of my triangle, and you can do Pythagorean theorem in order to figure out that this side is 17. I found that using Pythagorean theorem. Okay, So now I have all three sides of my triangle labeled. So now I can do, I'm going to put my theta here. I can do sine theta, cosine theta, tangent theta. And they're just going to be fractions, remember. I'm not going to be using opposite over hypotenuse for sine. I'm trying to use what we have in the chart above, the y value and the r value. So 15 over 17. And yes, it is the same thing as opposite over hypotenuse. I'm just trying to be a little bit more formal in my lingo now that I am in honors trig, okay? Cosine, adjacent over hypotenuse, aka the x value over the radius. So that is 8 over 17. Tangent is y over x. The y value is 15. The x value is 8. And if you can remember what the reciprocals are that go with those, sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. And all you do is you flip the fractions. So we have 17 over 15, we have 17 over 8, and we have 8 over 15. So notice the reciprocals here. The sine and the cosecant go together. The cosine and the secant go together. It's just the fraction flipped upside down. And the tangent and the cotangent go together. Okay? Now we have a weirder way of asking this next question. Why do they not give me an ordered pair? But I need to draw this. I need to find the 6 trig functions. I have an angle theta, again, standard position, you know what that means. If the terminal side of theta is defined by, whoa, this is kind of strange. Okay, here's what we're going to do for this one. Let me zoom in a little bit. If you remember anything from Algebra 1, what I'm going to try and do is get the y by itself, so I can graph like a y equals mx plus b situation. That means y equals negative 1/2 x if you just divide everything by 2. Okay, so that's step 1, get the y by itself. Step 2, I am going to actually graph this thing, like sketch it really quick. Negative 1/2 x, that means that my y-intercept is 0. And that means that my slope is negative 1/2. That means down 1, right 2. So I'm going to put a dot here, down another one, right 2 more. This is what my line looks like. This is Algebra 1, you guys. So you have to remember how to do this first of all. But we have this weird thing, x greater than or equal to 0. That means I'm only looking at the positive x-axis. So forget about this part of the line. And this is the terminal side of my triangle. Okay, so this is my step 2. So step 3 would be to take this angle that we have drawn now, and I'm going to blow it up so it looks a little bit, I don't know, more easy to recognize, I guess. So I'm in quadrant 4. My graph looks like this. We always draw our side up to the x-axis or down to the x-axis. Here's my theta. Now I need to figure out what this ordered pair is. Okay, I'm just going to use this one. Use the first one. What is that ordered pair? That's right 2, down 1. Interesting. So I'm going to put that here. I could also use this point. That's right 4, down 2. My fractions would reduce then when I did sine, cosine, tangent, etc. But I would still get the same answer. So doesn't that mean that this side is 2, this side is negative 1, and how would I find the hypotenuse again? Oh yeah, Pythagorean theorem. I believe that gives me radical 5 when you do Pythagorean theorem to find that. Okay, now I have all 3 of my sides labeled finally, and that was like a pretty long, lengthy explanation of how to draw that part. But now I can do my sine, cosine, tangent, and my other 3, and I can be done and move on to the next question. So here's what that looks like, you guys. You can pause the video, you can copy these down, you can check, you can like try them on your own and then check on whatever. But what I want to elaborate on here is what happened here. You guys have to remember how to rationalize, which I know might be a little bit annoying, but for sine, remember that's opposite over hypotenuse, which is this over this, or also what we're trying to get into now is the y value over the radius. So negative 1 over root 5. You can't leave a radical in the bottom, remember? So the way to get rid of that radical is to multiply it to the top and the bottom. and that gives you -1 radical 5 over just whole number 5. And so that is where that came from. I didn't write the -1. I just wrote negative radical 5, but that is how this turned into this. And these are the correct answers that we're looking for. You do have to rationalize your work. And then just remember, after you've done these three, you can do the reciprocal functions very easily. Tangent, just flip it, -2. It's easier to flip the unrationalized fraction because then you don't have to rationalize it again. So I just flipped this one to get my cosecant function. Just keep that in mind, a little bit of a tip, save you a little bit of algebra, okay? And you will get really good at rationalizing also. You'll probably be able to do it in your head by the time you're done with this homework assignment. Okay, I am going to pause there. What I want to do is save this number 3 for in class, and we'll do it together just to make sure everybody's on the same page. And then we have day 2 starting down here, which I'll make a separate video for, okay? Thanks for watching. Bring your questions to class, and I'll see you tomorrow.